My name is Hazim Gaber. I'm a mechanical engineer, and one of the designations I hold is an RCDD, or Registered Communication Distribution Designer. And over the next month, we're going to be looking at structured cabling systems designs. So, we're going to have an introduction today, and one of the first things we're going to look at, and by the way, Uh, I'm using this drawing tablet, so I'm going to write everything by hand for the most part. We're going to have a lot of other multimedia content, but I'm going to tend to write things out. So, first thing we're going to look at is the theory of data transmission. We're going to look at copper and optical fiber. How does a signal propagate over a copper cable? How does a signal propagate over an optical fiber? What are the types of circuits? What are the types of signals? Um, what are the cables made of? Well, you cut them open. We're going to learn about that. And then we're going to think about electromagnetism. Because electromagnetic radiation affects the quality of our signal. It degrades the signal. And we're going to think about how we can design a system that functions despite the electromagnetism and the methods we can use to counteract it. And then we're going to think about the design of telecommunication spaces. So, a telecommunications space, you might call it a network closet, server room, an MDF. We're going to think about how big it needs to be. We're going to think about where it needs to go. We're going to think about the type of cooling, heating, and ventilation that it requires. We're going to think about other things. And then we're going to discuss who decides where it goes and who approves the design. And then we're going to think about the distribution. So we're going to start off right away with some examples. So say I have an office building and we have internet coming into the building. We call this EF, or entrance facility. And then we have an MDF. And mind you, these might be the same rooms, basically the main distribution. So how do we get internet? Let's say this building is massive. And this is the first floor. And we've got a bunch of floors. And my screen isn't that big, so let's say we got 80 floors. And we got a ton of offices. Let's think maybe this isn't one of those weird math problems, but let's say the floors go on forever in both directions. Now, can we run a data cable or two data cables let's say every office has two datas and a Wi-Fi and a phone and camera and maybe a light switch that's PoE. You have a PoE LED, and that's just one office. So maybe I'm insane, but now we have an infinite number of cables running to our main server room, which is bad. We don't want to do that. So what we can do is we can build an IDF on every floor, or maybe even multiple IDFs. We're not going to do that, so we run cable from the MDF to every IDF, or maybe we even run, we let the IDFs, whoops, no, that is not good. I'm just gonna have to do, I'm not doing it again. So we're just gonna go back and draw our infinite office building. We have our MDF, and this goes on forever. So now we build an IDF on each floor, or maybe two, for example. Our building is really big, and we connect our IDFs to our MDF, and then we may connect one IDF to the other. We call this our backbone distribution. And then for each office, now we can run some datas from the nearest IDF. You get what I'm saying? So the blue cable is known as the horizontal. So we're going to think about the different types of horizontal distributions available. We're going to look at open office cabling because a lot of people now with Corona are working from home and they're not really, companies don't need that much office space. So do we really need that many data cables in the floor? And think about different ways to conserve. We're also going to look at uh, disabled Americans with Disabilities Act requirements. And then we're going to look at fire stopping. Which you may not be familiar with, or you may not think about in a building, but say I have a building, say this is your house. The government or the city, if a fire starts in your kitchen, it's going to spread and it's going to burn your whole house down in like 20 minutes. But if I have an office building and a fire starts here, we can't risk the whole building collapsing. So we have we call a fire rating. So it might be 1 hour or 2 hours, 3 hours. That's between the floors. So every floor, so if a fire starts, it won't spread to the next floor for a while. Gives the firefighters enough time to put it out. We can also have a fire rating between offices. So our MDF, for example, which contains our servers, we may want to put let's scrap that. Let's say this is our office building, and this is our MDF, and this is our IDF. We want to make sure if there's a fire that we don't spread the fire into the MDF. So we may give our room a 1 hour or a 2 hour fire rating. I'm going to talk about how we do that. We're also going to talk about, we go back to our example with our vertical or backbone cabling. When we penetrate a floor, or when we let cables out of our MDF or out of our IDF, how do we keep the joint, the opening, from allowing the fire to pass through? What do we do with that hole? And what kind of cable do we use? Now we're going to look at grounding. How do we, what happens if our communication system is struck by lightning or something? Or there's a short circuit? How do we keep the system safe? How do we keep people working on the system safe? How do we keep our devices safe? And then we're going to look at power distribution. What kind of power do we need? Do we need UPSs, alarms, and monitoring? And this depends on how critical our system is. So a system in a hospital or a bank or a data center is going to have more sophisticated power distribution than, say, a small office. And then I look at bureaucracy slash administration. We should actually call it record keeping. And then we're going to look at testing. How do we know the cable we installed is actually good? And then we're going to look at outside LAN. So that is cable coming into your building. Whoops. How does cable get into my building? Well, maybe an overhead pole with a wire, or there may be underground trench. It'll make sense. I'm going to cover maybe AV systems because there's a lot of special cabling involved. For example, Crestron makes there's a lot of also LED systems. There's other proprietary systems. There's video conferencing, video. There's also now sound masking, like white noise, which I find this topic to be very interesting to me. So maybe some of you will find it interesting. And then, since I come from an engineering background, we're also going to look at building automation, like BACnet, for example. And then we're going to think about OSI model, which is the 7 layers. And this kind of cross connects with my other course that I'm building on the network plus and security plus and the A plus. And you might want to think about those if you're interested in networking. Also going to look at Wi-Fi. Wi-Fi is very important. And then I'll look at security. Again, security. Also, we talk more about security in these courses. One thing this course doesn't cover yet, which this one, for as much as in depth as I like it to, is fire alarms. And I'm going to be expanding on this topic later. So we're going to look at UL and ULC certification. And then we'll look at data centers, which are a special kind of distribution with more redundancies. and more security. And then we'll look at some applications. I should say this is really an application. Another application that we're going to look at in depth because of its special requirements is healthcare. And some of the technologies that we've implemented for healthcare are nurse calling systems, RFID, also have monitoring, AV, records, patient records, also known as EMR, electronic medical record. And then we will look at residential. And we have apartments and we have small houses. And we have 30,000 square foot and 10,000 square meter houses. And then we will look at administration and project management. And that includes engineering, includes special design, includes building codes, and there's different codes here. So there's your state or provincial code or federal code. Then you have your electrical code. And then you have cabling standards. So I'm following the BICSI TDMM or Telecommunication Distribution Methods Manual. Your client may also have their own standards. For example, the federal governments have standards. So don't be intimidated. If you have any questions, feel free to ask me. Leave a comment or send me an email. And I look forward to working with you.